Today we're going to talk about the domains of rational functions and how to find them, including whether to determine whether an x value is an asymptote or a whole of the function without actually having to graph it. So, first of all, let's take a look at some situations. What is a rational function? Well, it is the ratio of two polynomial functions. So you can see the root there, ratio. Let's go ahead and take a look at these two polynomial functions. F of x is equal to 4x minus 2 times x minus 5. This is the factored form. And then g of x is 4x minus 2 times x plus 2, again, factored form. Now let's consider the rational function f of x divided by g of x. Now, to figure out where this function is defined, we need to first of all find where it is not defined, which we only care if something is not defined at zeros of our denominator or negative numbers for an even root. So since we're only dealing with the denominator, we just check to see where a function g of x is equal to 0. And then we need to make sure to exclude those points. Which, by doing this, 4x minus 2, that will solve for 1/2. And x plus 2 solves for negative 2. Which we then go ahead and put in this setup here. Note that both sets of points have rounded brackets. Because these points are not included in the domain. Also make sure to have your intervals set up in the proper direction. So you want to start at lower numbers and go to higher numbers. Now, are these points asymptotes or wholes? Well, for this we have to determine what happens at each of these. So let's go and take a look at the point negative 2, which we got. If you put it in our numerator, we get f of negative 2 is 70. In our denominator, well, we know it comes out to 0. In general, if our denominator comes out to 0, but the numerator does not, then it's going to be an asymptote. Well, we also have the other situation where if f of 1/2 is 0 and g of 1/2 is 0, so both of them are 0, we also want to make sure that both factors cancel from the numerator and denominator when you simplify it. Which when we simplify the above equation, 4x minus 2 and 4x minus 2 will end up canceling, which will leave us the function x minus 5 divided by x plus 2. So that factor is completely gone, so that means that it will be a whole. So let's go ahead and take a look at the graphical representation of this. So we have our graph, as you can see here, which shows the asymptote at 2. If we zoom in over here at 1/2, we can see that the Desmos is telling us undefined. Let's go ahead and change things up a little bit. So let's have an f of d and g of d. So when d is 1/2, we get 0 and 0. Which when we plot these two functions, we'll see that they cross at that point, but that does not mean they have a whole whenever they cross. They have to cross at 0. Now what happens if I add 4x minus 2 to my denominator as an additional term? Well, it means we're still going to be 0 at that point for x minus 2. But now that's easily can be seen to be an asymptote as well, even though they're both 0 at that point. So keep that in mind. Because what that means is we have 4x minus 2 times x minus 5 divided by 4x minus 2, x plus 2, 4x minus 2. This 4x minus 2 and this 4x minus 2 will cancel out, but a 4x minus 2 will be left in the denominator. which means it would be an asymptote. Hopefully that helped clear things up for you, and we will see you for the exam.